In this lecture on industrial robotics, we will be dealing with RoboCell design and control. In particular, we will be dealing with the topics on multiple robots and machine interference, considerations in workcell design, and workcell control. We will deal with multiple robots and machine interference. In some RoboCells, there will be more than one robot required to perform the application. The inline RoboCell is a common example of this situation. In other cases, one robot will work with more than one machine in the cell. Either the robo-centered cell or the mobile RoboCell are illustrative of this possibility. In either of these situations, care must be taken to ensure that the different pieces of the equipment do not interfere with one another. There are two ways in which this interference can occur. The first case involves physical interference of the robots where the work volumes of two robots in the cell overlap each other. In this situation, the danger of collision exists between the robo arms. This is most easily prevented by separating the robots by an adequate distance to avoid the problem. However, there are some applications in which it is desirable for two robots to share the same space. An example would be where one robot places a work part at a certain location and the second robot picks the part up. The location must be in the work envelopes of both robots. Accordingly, an alternative approach is to coordinate the programmed motion cycles of the two robots so that the arms are never close enough to risk a collision. The second type of interference is when there are two or more machines being serviced by one robot and the machine cycles are timed in such a way that idle time is experienced by one or more machines while another machine is being serviced by the robot. This is called machine interference and it is a common problem encountered when a human worker is assigned to service multiple machines. The difference between machine interference with a human worker and the machine interference with a robot is that the amount of interference in the human cell is affected by variations in worker cycle times and by the worker's level of effort. With greater variation in the cycle time and a lower effort level, the machine interference will tend to be greater. In a RoboCell, the robot's cycle time will not be affected by effort level, and the amount of cycle time variation will be significantly less than for human work. Machine interference can be measured as the total idle time of all the machines in the cell as compared to the operator or robot cycle time. The measure is most commonly expressed as a percent. Refer the text for a typical example. Example 11.1. Other considerations in workcell design. Some of the other issues that must be considered in the design of the workcell are the following. 1. Changes to other equipment in the cell. To implement the workcell and interface the robot to the other equipment in the cell, alterations will often have to be made to the equipment. Special fixtures and control devices must be devised to permit the cell to operate as a single integrated mechanism. Examples of these fixtures and controls include work holding nests and conveyor stops to position and orient the parts for the robo, changes in the machines to allow the robo arm to gain access to the equipment, and limit switches and other devices to interface the various components in the cell. Two, part position and orientation. For raw work parts being delivered into the cell, it is important that the robo have a precise pickup location to get the parts from the conveyor or other work handling system. At this pickup point, the parts must be in a known orientation to enable the robo to grasp and hold it consistently and accurately. During subsequent processing within the cell, this part orientation should not be lost. A method for achieving these objectives of part positioning and orientation must be designed into the work cell. Three, part identification problem. In cells where more than one type of part is processed or assembled, a method of identifying the particular part type must be determined. This can be done by any of a number of automated means involving optical techniques or limit switches to sense differences in size or part geometry. 4. Protection of the robo from its environment. In certain types of applications, examples spray painting, hot metal working operations, a means of protecting the robo from the adverse effects of its environment must be provided. Five, utilities. Providing the necessary utilities, example, electricity, air pressure, gas for furnaces, etc., must be included among the factors considered in the design of the work cell layout. 6. Control of the work cell. The activities of the robot must be coordinated with those of the other equipment in the cell. This subject is referred to by the term workcell control. 7. Safety. A means of protecting human personnel from harm in and around the robot workcell must be provided. This is generally accomplished by means of fences or other barriers and by designing a safety monitoring system to interrupt the cell operation if unsafe conditions are encountered. Now we will move on to the topic of workcell control. In addition to the problem of designing the physical layout of the RoboCell, another problem is concerned with coordinating the various activities that occur in the cell. Most of these activities occur sequentially, but simultaneous activities can also occur. There are other factors such as the safety of the human personnel which must also be considered. Coordination of these various activities is accomplished by a device called the workcell controller or workstation controller. The functions performed by the workcell controller can be divided into three categories: sequence control, operator interface, and safety monitoring. These functions are accomplished either by the robot controller itself or by a higher level control device such as a programmable controller. The robot controller usually has a limited input-output capability to permit interfacing with other pieces of equipment in the cell. If the control requirements to operate the cell become at all complicated, then a higher level controller is needed. One, sequence control. Sequence control is the primary function of the workstation controller during regular automatic operation of the workcell. It includes the following kinds of control functions. 1. Control of the sequence of activities in the workcell. 2. Control of simultaneous activities. 3. Making decisions to proceed with the work cycle based on events that occur in the cell. 4. Making decisions to stop or delay the work cycle based on events that occur in the cell. These functions occur during the normal operation of an average robo workcell. Please go through example 11.2 and example 11.3 in the text for practical cases. 2. Operator interface. The purpose of the operator interface in workstation control is to provide a means for human operators to interact with the operation of the cell. There are several situations where this would be required. Among the most important cases are the following. A. The human is an integral part of the workcell. B. Emergency stop conditions. C. Program editing or data input by operator. The first situation is where the human worker plays an integral role in the operation of the cell. The human performs a portion of the work cycle and the robot performs a portion of the cycle. In this situation, there is a need to allow for variations in the time required by the operator to perform the manual part of the cycle. In a robotic cell, this can be easily accomplished by means of stop-start controls placed conveniently for the operator. The operator uses these controls to regulate the robot cycle as required by the situation. Refer example 11.4 in the text. It illustrates the need for using operator controls to allow for variability in operating pacing. The second situation involves an emergency in which a human worker needs to prevent continued operation of the robot cycle. The reason for the emergency may be a safety problem or an irregularity in the work cycle that is potentially destructive to the robot or other equipment in the cell. A safety problem might arise when some people walking through the plant has unwittingly intruded into the robot's space. An irregular event in the work cycle might be that the robot has grasped the work part improperly for loading into a machine, and this would cause damage to the machine or the associated tooling during processing. In either case, the human worker located in the cell would have reason to interrupt the operation of the robot cycle until the emergency situation was corrected. The third requirement for operator control is to perform editing of the program or other similar input functions. Some robot controllers require that the robot be in a non-operational mode when changes are made in the program. The more flexible controllers allow for editing to be accomplished while the robot is performing its regular cycle. Three, safety monitoring. In addition to the operator's ability to override the regular work cycle in the event of an observed safety hazard, the workcell controller should also be capable of monitoring its own operation for unsafe or potentially unsafe conditions in the cell. This function is called safety monitoring or hazard monitoring. The reference book used for this lecture is titled Industrial Robotics, Technology, Programming and Applications, authored by Mikkel P. Gruer, Michel Weiss, Roger Nagel, Nicholas Audrey and Ashish Datta. This is the second edition of this book, published by McGraw-Hill Publishers. Thank you.